Hi guys, this is Dr. G here, and in this video we are going to talk about electrophilic addition reactions of alkynes, especially addition of HX and halogens or X2. So X basically stands for halogens, okay? So before watching this video, I highly recommend that you guys study the videos that I have posted on electrophilic addition of HX and X2, or electrophilic addition of halogens for alkenes, because the knowledge that you gain from alkene chemistry is going to be vital in understanding these reactions easily. Okay, so in here we are going to talk about the electrophilic addition of protic acids such as hydrogen chloride, hydrogen bromide, or hydrogen iodide, and also electrophilic addition of halogens, mostly actually chlorines and bromines addition. So let's first talk about the addition of HX. So the addition of HX happens according to Markovnikov's rule. So if you remember what is Markovnikov's rule, okay, in layman terms we can say that according to Markovnikov's rule, hydrogen goes to the carbon with more hydrogens, and then the halogen or the halide goes to the carbon with less hydrogen. So in other words, rich gets richer. Okay, hydrogen, we consider hydrogen is like money. Okay, so hydrogen tend to go to the carbon with more money. So electrophilic hydrogen will go to the carbon with more hydrogens, and the nucleophile, which is the halide, will go to the carbon with less hydrogen. So that is something that we discussed in detail in alkene chemistry, but in alkyne chemistry we will use that knowledge. Okay, so here is an example. So what I have here is one hexane. Okay, one hexane. So basically in one hexane you have two carbons that share the triple bond, so both carbons are sp hybridized. So let's categorize these two carbons as rich and poor. Okay, so the carbon to your right hand side is rich and the next carbon is poor. Why did we say that? Because the rich carbon, the number one carbon, has one hydrogen, but the number two carbon has no hydrogen. So if you have more hydrogens, you are rich. If you have less hydrogens, you are poor. Okay, so according to Markovnikov's rule, rich gets richer, so the rich carbon should get the hydrogen. So as you can see, the rich carbon has received the hydrogens. Okay, which means the poor carbon is getting the nucleophile, which is the bromide ion. Okay, so in here alkynes are like two double bonds. So basically when you add HX, you are adding two HX. Okay, so basically you are adding two hydrogens to the rich carbon, and you are adding two halides to the poor carbon. Let's take another example. Okay, let's take another example. So let's say we have an alkyne like this. Okay, how many carbons do you have in this alkyne? How many carbons do you have? You have 1, 2, 3, 4, 5 carbons. So this is one pentyne. Okay, this is one pentyne because you have 5 carbons. Okay, so what we are going to do here is that we are going to add let's say HCl. Okay, we are going to add HCl to our alkyne. Okay, we are going to add HCl to our alkyne, and then of course this is a terminal alkyne. This is a terminal alkyne. What did I say? It is terminal because the triple bond is in one side or one terminal. Okay, so it is close to a terminal. So that is why I said that this is a terminal alkyne. So in here this addition reaction will basically add two hydrogens to the rich carbon. Okay, it will add two hydrogens to the rich carbon, or the carbon with more hydrogens, which is the rich carbon. Okay, so it will add two hydrogens to the rich carbon, and it will add two chlorides to the poor carbon. Okay, so just simply draw a 5 carbon chain. Okay, here's the 5 carbon chain, and then the rightmost carbon is our rich carbon, so it got two hydrogens. Perfect. So the poor carbon should get two halogens. So in here it's two chlorines, right? So this carbon will have two chlorines. This is how it happens. Okay, the addition of protic acids will happen according to Markovnikov rule. Markovnikov rule. Okay. So let's say we have an internal alkyne. Let's say we have an internal alkyne. Let's take a different alkyne. Okay. So let's take this as our alkyne. Okay. So this is an internal alkyne. This is not terminal. The triple bond is not to one side. Okay. So this is an internal alkyne. So the thing about internal alkynes is that they both carbons have a triple bond. I mean, the sp hybridized carbons have a triple bond, and the fourth bond is actually a carbon-carbon bond. So both carbons have no hydrogens. So there is no rich carbon nor a poor carbon. Okay, there is no rich carbon nor a poor carbon. So when you are adding the hydrogens or halogens, you don't have to worry about which carbon is getting the halogens and which carbon is getting the hydrogens. So you can easily put the two hydrogens in one carbon and the other two halogens in the remaining carbon. Okay, so let's use HBr here. Let's use HBr here. So in this molecule you have 1, 2, 3, 4, 5, 6 carbons. So draw a six carbon chain. Okay, so 1, 2, 3, 4, 5, 6. Okay, so here is your 6 carbon chain, and then your double bond was between these two carbons, right? Your double bond was between, I mean, the triple bond was between these two carbons. So one carbon will get the two hydrogens and the other carbon will get two bromines. Okay, the other carbon will get two bromines. Okay, so you have to worry about the Markovnikov rule if you have a terminal alkyne. This one is a terminal one. If you have a terminal alkyne, you will worry about the Markovnikov rule. Okay, all right, so that is it. So let's talk about the addition of halogens. Okay, addition of halogens. So basically addition of halogens is very simple because you don't have to worry about the Markovnikov rule. Why? Because both carbons are getting the same old halogen, right? So you don't have to worry about Markovnikov rule. So therefore your product will basically have two carbons with two halogens each. Okay, so your product will basically have two carbons with two halogens each. Look at these two carbons. They both got two bromines each, right? So the two carbons that are sp hybridized, okay, will get two halogens each. So which is a very simple reaction. Okay, which is a very simple reaction. So here's another example in case if you want to see more examples. Okay, let's take an alkyne. Here is an alkyne. Okay, so let's add bromine to it. Okay, just like in alkene chemistry. Okay, you will add bromines to it, so both carbons will get bromines. Okay, so after addition of bromines, I mean, you will have a 5 carbon chain, so it is not going to change. Okay, so you have 1, 2, 3, 4, 5 carbons. Okay, so first draw a 5 carbon chain, and then the two carbons that shared the triple bond now will get two bromines, right? So Br, and then Br. Here you go. That is your product. Okay, that is your product. Very straightforward. All right, so let's talk about the similarities of the alkene addition and alkyne addition. So the similarities is basically that they are both the electrophilic addition reactions. The difference is that in alkyne you are basically adding two protic acid molecules or two halogen molecules. Okay, but in alkenes you're only adding one. Okay, so you're only adding one, and basically when you're talking about HX addition, it will happen through Markovnikov rule in both occasions. Okay, but the difference is that for alkene addition it will go through an alkyl carbocation. So the intermediate is an alkyl carbocation, if you remember. Okay, but in alkyne chemistry, it will basically go through a vinyl carbocation. It will basically go through a vinyl carbocation. It will basically go through a vinyl carbocation. Okay, so that is the difference. Okay, so the intermediate will be different, but the other things will remain similar to your alkene chemistry. With that, I'm going to conclude this video. Okay, so if you have any questions, just you can email me or you can send me a comment. All right, so you guys have a good one, guys. Take care.